Hello friends, in this AV we are going to solve a few numericals from the third exercise of the chapter Current Electricity, that is exercise 8C. Now for this exercise we are going to use these formulas. Work done is equal to Q multiplied by V, where Q is the charge, V is the potential difference, or work done is equal to V into I into T, or work done or heat produced is equal to I square RT, or work done is equal to V square T upon R. Or for calculating power, we are going to use P equal to W by T, that is work done per unit time, or power is equal to V into I. V is the potential difference or voltage, you can say, multiplied by current, or power is equal to V square upon R, or power is equal to I square R. These are the formulas that we are going to use for the numericals. Now let's check the very first numerical of this exercise. It says an electric bulb of resistance 500 ohms draws a current 0.4 ampere from the source. We have to calculate the power of the bulb and the potential difference across its end. So let's write the given things. So here we have written the given things. Resistance is 500 ohms, current is 0.4 ampere, and first part of the question asks us to calculate the power. So power, P is equal to, we have been given R and I. So from the formula you can see P is equal to the formula which relates power, resistance and current is this equation. So P is equal to I square R. I is 0.4 square multiplied by the resistance, that is 500 ohms. So this is going to be 0.16 multiplied by 500, that is equal to 80 watt. The second part of the question asks us to find out the potential difference. Now potential difference can be found out. We have the formula P is equal to VI. So from here V will be equal to P upon I. We have calculated the power to be 80 watt divided by the current, which is given as 0.4 ampere. So 0.4, when we divide it, it comes to 200 volts. Now let's check the second question. Second question says a current of 2 ampere is passed through a coil of resistance 75 ohms for 2 minutes. The time is given in minutes. We'll convert it into seconds by multiplying it with 60. How much heat energy is produced and how much charge is passed through the resistance? So let's write the given things first. So here we have written the given things. Current is 2 amperes, resistance is 75 ohms, and time is given as 2 minutes. So we convert it into seconds. We have to find out the heat produced. So we know that work done is given as I square RT. We have been given the current, the resistance and the time. So we use this formula and we have the work done or the heat produced is equal to I square RT. We have the value of I, that is the current, is 2 ampere. So 2 square multiplied by resistance is 75 ohms multiplied by 120. So when we do it, we'll come to the answer as 36,000 joules. And the second part of the question asks us to find out how much charge is passed. So charge means Q. So we know that Q is given as IT. We have used this formula in the previous exercise. Q is equal to IT. So I is the current, that is 2 amperes multiplied by time is 120 seconds. So 12 into 2 is 24. So 240 coulomb is the charge that is being passed through it. Let's check the next question. It says calculate the current through a 60 watt lamp rated for 250 volts. if the line voltage falls to 200 volts, how is the power consumed by the lamp affected? Now for this question, first of all we have to find out the current, and then to find out the second part, that is how will the power consumed by the lamp affected, we'll have to first find the resistance and then the power with the new voltage. So let me just write the given things first. So here we have written the given things. Power P is equal to 60 watt and voltage is 250 volts. So we know the formula, power is equal to V into I, that is voltage into current. So from here we can find out the current as power divided by the voltage. So power is given as 60 watt divided by the voltage is 250. So when you divide it, we will find the answer as 0.24 ampere. Now the second part of the question says how will it be affected when the voltage drops to 200 volts. So for this, first of all we have to know the resistance. So resistance of the bulb, if you're writing it in your copy, please write the full word, that is resistance, is given as V square by P. We are using this formula. P is equal to V square upon R. So R will be equal to V square upon P. So with this we have the value of V, that is voltage, is 250, square it, divided by the power, that is 60 watt. So if you divide it, you can use a calculator because ICSE allows calculator. Then we have 1041.6 ohms. This is the resistance of the bulb. Now we will calculate the power using the new resistance. This will tell us how will the bulb be or the resistance be affected, or what will be the power consumed. So if voltage falls to 200 volt, then power consumed will be P is equal to V square by R. We are using the same formula. Now the new voltage is 200 volt, it's not 250 anymore. So 200, square it please, divided by the resistance that we have calculated, 1041.6 ohms. Then this will come to 38.4 watt. This is how the power will be consumed, or this is the new power that will be required. Now let's go to question number 6. It says a bulb of power 40 watt is used for 12.5 hours each day for 30 days. Calculate the electrical energy consumed. Here what you can do is just multiply 40 into 12.4 into 30. You will get the answer. You'll get it as 15,000 watt hour, which when converted into kilowatt hour, it will be 15 kilowatt hour or 15,000 watt hour. So I'm not doing it. Let's move on to question number 8. This question says an electrical appliance having a resistance of 200 ohms is operated at 200 volts. So resistance is given and voltage is given. Calculate the energy consumed by the appliance in 5 minutes in joules and in kilowatt hour. We have to just calculate the energy but in two different units. So let's write the given things here. So here we have written the given things. The resistance given is 200 ohms, voltage is 200 volts, and time is given in minutes. We have converted it into seconds by multiplying it with 60. We have to calculate the energy, and energy is nothing but the work done. So here we have been provided with voltage, time and resistance. So we will be using this formula. W is equal to V square T upon R. So here the energy is V square T upon R. Now the first part of the question says we have to calculate energy in joules. Now, so E is equal to V square T upon R. I am directly putting the values. V is 200 volts. So 200 square multiplied by the time, that is 300 seconds, divided by the resistance R, which is again 200. So 200 and square will cancel out. 3 into 2 is 6. So it comes to 60,000 joules. Now the second part of the question says we have to calculate it in kilowatt hour. In kilowatt hour. So if you have read the chapter, you will come across this conversion thing, the relation between kilowatt hour and joule. It is 1 kilowatt hour is 3.6 into 10 raised to the power 6 joules. Now from here 1 joule would be 1 divided by, we are just taking this part, this whole thing this side. So 1 divided by 3.6 into 10 raised to the power 6 kilowatt hour. So if 1 joule is this much, 60,000 joules would be 60,000 joules would be this multiplied by 60,000. So 1 into 60,000 is 60,000 divided by 3.6 into 10 raised to the power 6 kilowatt hour. Now please calculate it. It would come to 0.0167 kilowatt hour. Now question number 11 is important, but they have already given the answer there. Kindly go through it, you will understand. Now the next question that we will be taking is question number, let's take number 12. It says two bulbs are rated 60 watt and 220 volts and 60 watt and 110 volts respectively. Calculate the ratio of their resistances. So we have to calculate the resistance for both and then find the ratio. So let's write the given things. So here we have written the given things. The voltage for the first appliance is 200 volts and power is 60 watt. Voltage for the second appliance is 110 volts and the power is the same, that is 60 watt. Now we have to calculate the ratio of their resistances. We know the formula for resistance is R is equal to V square by P, because that is the only formula which connects R, V and P. So for the first appliances, let's write R1 as the resistance one, that is V1 square upon P. So let's put the value. V1 is 200 square by P, that is 60, or you can write it as 200 into 200 by 60. Similarly R2 is V2 square by P, that is V2 is 110 volts. So 110 multiplied by 110 divided by 60. So since we have to find out the ratio would be, the ratio is R1 by R2. The ratio is R1 by R2, that is equal to, let's put the values, 200 into 200 divided by 60, then 110 into 110 divided by 60. 60 and 60 will cancel out. You have 200 into 200 divided by 110 into 110. So after cancelling everything, the ratio would come is to 4:1. So this is the answer. After number 12, let's try number 13. It says an electric bulb is rated 250 watt and 230 volts. Calculate we have to calculate first the energy consumed in 1 hour. This is the time, and the time in which the bulb will consume 1 kilowatt hour energy when connected to 230 volts mains. So let's write the given thing first. So here we have written the given things. Power is equal to 250 watt and voltage is 230 volts. For the first part, that is to calculate the energy consumed, energy is equal to power into time. Time they have given us as 1 hour. So time is equal to 1 hour into 60 will give us the seconds. So we can use it here. Power is 250 watt multiplied by the time, that is 3600. So this will come to 9 into 10 raised to the power 5 joules. Now the second part of the question says we have to the time in which the bulb will consume this much of energy. So energy has been given to us, we have to calculate the time. So we'll use the same formula, but instead we will write the energy as 1000 watt hour, that is 1 kilowatt hour, what they have given. Power remains the same, that is 250 multiplied by the time. So time will be 1000 divided by 250, that is 4 hours. Now after this, let's try question number 15. It says a bulb is connected to a battery of potential difference 4 volt and internal resistance of 2.5 ohms. A steady current of 0.5 ampere flows through the circuit. We have to calculate the total energy supplied by the battery in 10 minutes, the resistance of the bulb, and the energy dissipated in the bulb in 10 minutes. So let's write the given things. So here potential difference or the voltage is 4 volts. Resistance of the battery, we are denoting it with RB, is 2.5 ohms. Current is 0.5 ampere and the time is 10 minutes. So multiply it with 60 and you get 600 seconds. So the first part is to calculate the total energy supplied. So energy is equal to V square T upon R. So before using this, I need to know R, that is the total resistance, which has not been supplied to me. So I'll just use the formula for resistance. R is equal to V equal to IR, so R will be V by I. V is 4 volts and the current is 0.5 ampere. So this gives me 8 ohms as the total resistance. So now I use this formula. E is equal to V square T upon R. So V is 4 volts. So 4 square into T, that is time is 600 seconds, divided by the R, that is we have just calculated 8. So after calculation 16, 8, 6, it should be around 1200 joules. Now the second part of the question says the total resistance of the bulb. So the total resistance is, we know that total resistance is what we have calculated as R, that is 8 ohms. Now resistance of the battery RB is given as 2.5 ohms. So therefore resistance of the bulb would be the total resistance, that is 8 minus the resistance of the battery. 8 minus 2.5, 0.5, so it would be 5.5 ohms. And the third part is energy dissipated in the bulb in 10 minutes. That is the heat produced in 10 minutes. So that is equal to energy dissipated in 10 minutes, heat or energy is equal to I square RT. I, that is the current, is given as 0.5 ampere, so square it, multiplied by R, that is for the bulb is 5.5, multiplied by the time, that is 600 seconds. So here this would come to 825 joules. Now the rest of the questions you can just use the formulas that we discussed in the beginning of this AV, and as I always tell you, please do not practice only the exercise numericals. Do practice the solved numericals given in the book as well. Thank you so much. Happy learning. God bless.